Hi everyone, welcome to my YouTube channel. Today we will be covering two problems. The first problem is finding the middle of a linked list, and the second problem is deleting the middle node of a linked list. So let's have a look at our first problem. So here we are given these two linked lists. The first linked list is of length even. Here in the example, the length of this linked list is 4, and the second linked list, its length is odd, and the length is equal to 5 here. So initially we could be given these two linked lists, and for the first example the head is pointing to the node 1. For the second example as well, the head is the node 1, and we have to return the middle node of both of these linked lists. So let's have a look at our even length linked list. So for this example of length 4, as we know that since the length is 4, so the middle could be the node 2 or node 3. So either one of them would be the middle node. So which one of them would be the middle? So the node 3 should be the middle one, because when we are splicing the linked list into two halves, so we cut our linked list somewhere here. So basically the middle node would be the head of our second half. So the second half of our linked list would be node 3. So this would be the second head. So our second half for our first linked list would start at node 3, and this node 3 would be the middle element of our linked list. So for the second example, as we know, the length is 5. So from this example it's clear that the middle would be node 3, as before node 3 there are two nodes, and after node 3 there are two nodes. So here it's straightforward that node 3 should be the middle of the linked list. So now let's have a look at how we can solve the problem of finding the middle node of a linked list. So the first approach will involve finding the length of a linked list. So we can find the length of a linked list by iterating over the linked list in O of n time, and the way we are iterating over the linked list is we will start from the head, and we will increment the length variable, and once we reach the null pointer we are done. And once we find the length pointer, then we can find the middle element using length by 2 plus 1. So if the length is even, here in this case if the length is 4, then the middle node is going to be 4 divided by 2 plus 1, which is the third node. And similarly, if the length is odd, then again middle node is going to be 5 divided by 2 plus 1, which is the third node. Here the third node is this node 3, and for the even case the middle node is going to be node 3, which is also the third node. So this example is involving finding the length of the linked list, which is O of n time and O of 1 space, which is great in terms of time complexity. But can we do better in terms of time? Like, can we reduce the constant? Can we reduce the constant in the big O notation? Well, the answer is yes, we can do better. And the better solution will involve fast and slow pointers that we discussed in our previous videos. So let's have a look at that approach and try to figure out an algorithm on how we can find the middle node. So now let's try to understand the approach of slow and fast pointers in finding the middle of a linked list. So here we are given a linked list of length 4, which is even. So as we discussed from slow and fast pointers, initially we are going to use two pointers, slow and fast. So initially we are going to initialize them to head, slow and fast. And as we know, for this example the middle should be the node 3. So let's see how we can find it. So we know that we have to increment the slow pointer by one step and fast pointer by two steps. If this is not clear, then please see my video on linked list cycle and linked list cycle 2. This would be clear by watching that video. So let's have a look at this. So here we are given slow and fast pointers and we have to iterate our linked list. So let's try to debug by incrementing the slow pointer by one step and fast pointer by two steps. So at the next iteration, what we're going to have is we're going to have our linked list state like this. We are given this to node 3 and node 4. So if we increment the slow by one step, it would be here. My fast would be here. If we incremented it by two steps, so at next step my slow pointer would be here and my fast pointer would become null, which is here. So as you can see, when the fast pointer is becoming null, my slow pointer is at the middle node. And what will happen if the linked list length is odd? So let's try to draw an example in which our linked list length is odd. So let's see an example of length 5. So here we have this, and we initialize our slow and fast to the head, which is node 1. So if we increment the slow pointer by one step and fast by two steps, what we are going to have is our slow would be here, fast would be here after one iteration. At next iteration, slow would be here and fast would be here. So as we know that our node 3 is our middle node in this example, and the state of fast pointer is that fast.next is null. So when fast.next is null, we have found our middle node for linked list which has odd length. So our while loop, what it's going to have, it's going to have checks on while fast is not equal to null and fast.next is not equal to null. Only then we have to increment these pointers. So only then we have to increment slow by one step and fast by two steps. And once we are done with this while loop, we can simply return our slow pointer, and this slow pointer will be our middle node. This slow pointer will be pointing to our middle node. So this was like simple example of node 4 and node 5. Let's have a look at our edge cases, like if we need to add special checks for our edge cases. So our first edge case would be when there is just one node. So let's see what's going to happen then. So here our slow would be this, fast would be this, and as we have checked here that fast.next must not be null, only then we increment these two pointers. So here fast.next is null and slow is 1. So in this case the middle node would be node 1. So here it's only one linked list node. Let's have a look at linked list node, linked list with two nodes. So here we have 1 and 2. So our slow and fast would be this, and what's going to happen is our fast is not equal to null, the check here, and fast.next, which is node 2, that's also not equal to null. So what we are going to do is we can increment these pointers, and our slow pointer would be here and fast will become null, and we will be done with this while loop, and we can simply return the slow pointer, and in this case the node 2 would be our middle node. And for the example where head is null, we can simply return head and we'll be done. So this is the approach of using slow and fast pointers to find the middle of our linked list. So let's have a look at the code implementation. And one more thing you should note is that for linked lists of length even, the fast pointer will never be at the last node. It is going to be at the second last node. And for the linked list of length odd, the fast pointer will be at the last node. So that is why these both checks work. Fast is not equal to null and fast.next is not equal to null. So basically these two checks are for even and odd lengths. So this check is for even length and this check is for odd length, and this covers like both the odd and even cases and also all the test cases. So that's why we have this. So now let's have a look at the code implementation of finding the middle of a linked list. So here we are given this function that we have to implement, and we are given the head of the linked list. So as we discussed, we have to define two pointers, slow and fast. So let me first define slow equal to head and fast also equal to head. So based on our algorithm walkthrough, we know we have to use a while loop where we are going to check fast is not equal to null and fast.next is not equal to null to cover both the even and odd cases, and we have to increment slow by one step and fast by two steps. And at the end, when while loop is going to finish, the slow pointer is going to be at the middle node. So here, if the head is null, we don't need to check head equal to null separately, because if head is equal to null, then slow will be null and fast will also be equal to null, and it is going to simply return null, and we don't need like any extra head equal to null checks, so we don't need this. And so yeah, let's try to run this, and yeah, it works, so which is good, and I'll see you in the next problem. So now let's see the problem of deleting the middle node of a linked list. So here we have this linked list of length 5, and as we know from our discussion so far that the middle node would be this node 3. So let me call this mid. So what do we need in order to delete this node from the linked list? We simply need to remove it from linked list, and after removing it, our new linked list should be this 1, 2, 4 and 5. And what do I need in order to remove this middle node? So if I only have the reference to my middle node, can I delete this node? The answer is no. So what else do I need to delete this middle node? So to delete this middle node, I also going to need the reference to the previous node. And if I have the reference to the previous node, what I can do is I can simply update previous dot next equal to previous dot next dot next. So how we can save this previous pointer? So to work with previous pointers, as we have discussed in our earlier videos, that whenever there is a use of previous pointers, we can make use of dummy nodes for linked list problems. So let's try to draw this again. And here we have our linked list again. And what I'm going to do is I'm going to create a dummy node just before head. So this would be my dummy node. And I'm going to use the similar slow and fast pointers approach. So here I'm going to initialize my slow pointer as head and fast pointer as to also head. And along with slow and fast pointers, I'm also going to use one more variable which will be previous, and it would be set to dummy. And I'm going to use the same logic that I used to find the middle of the link list. And in our while loop. So where we had fast is not equal to null and fast.next is not equal to null. In this while loop, we are going to add another iteration for previous equal to previous dot next. So we have to update the previous pointer by one step only because it has to be always behind slow pointer. So that's why we update previous by one step. So along with incrementing slow and fast, we simply add this increment of previous pointer, and the final state of my linked list pointers would be this. So here I have my dummy node. This is node 1, this is node 2, this is node 3, 4 and 5. So my slow pointer is going to be here and my previous is going to be here. My fast is, as you know, is going to be here. So I can simply update the previous dot next reference to point to this node, and my new linked list is going to be this one, and at the end I can simply return dummy.next and we will get the newly modified linked list. So now let's have a look at the code implementation of deleting the middle node of a linked list. So here we are given this question and we are given the head of the linked list and we have to return the modified linked list. So here we have to implement this given function delete middle. So from our discussion so far, we have to use slow and fast pointers and previous pointer. So let me first define the slow and fast pointers and initialize them to head, fast equal to head. And also what I need is I'm going to need a dummy node. So this node dummy to new list node -1, and I have to set dummy.next as head. And after I create my dummy node, I can create my previous and initialize it to dummy. And from our fast and slow pointers discussion in finding the middle of the linked list, so we are going to use the same code here where we find the middle of the linked list and increment the previous pointer, and at the end we update the previous dot next and simply return dummy dot next. So here we have while fast is not equal to null and fast dot next is not equal to null, and we increment our slow pointer by one step and fast pointer by two steps, and additionally we have to increment our previous pointer by one step as well. And once we are done with the while loop, we can simply delete the middle node by setting previous.next as previous.next.next, and we can simply return dummy.next, and this will give the head of the modified linked list. So let's try to run it, and it works, which is good. You can try to submit it as well and it will work. So that's good, and thank you for watching, and I'll see you in the next video.